Hi guys, so today we're going to talk about the periodic table of elements. So last week we had a lesson on the basics of atoms, which make up everything. They are made up of smaller things, and we'll talk more about that as we go along too. But this week we're going to look at the periodic table of elements, which sorts out all the elements known to humans at this time. And so we can see how they relate to each other and how they are similar and how they are different. So last week we looked at the Bohr model and we talked about protons, neutrons, and electrons and where they go in an atom. We're going to look more in depth with that as we go along, but first we need some basic understandings of the elements and of the periodic table before we can really get into the specifics of that and of bonding and chemical reactions. So first, a reminder, a little bit of what we learned last week here. So here, you guys will notice on your periodic table that at the top there's an example square. Yours is hydrogen. I thought that was a bit simplistic, so I did mine for sodium, whose chemical symbol is Na. So the chemical symbol is the abbreviation that we use to represent the element in equations. So down here I have NaCl. If you look on your periodic table over in the groups to the right, you will see Cl is chlorine. So when you combine an atom of sodium and an atom of chlorine, you get a molecule of sodium chloride, which is table salt. So, but we don't want to write out sodium chlorine every time. That's annoying. NaCl is a much faster way to do it, and so we use the symbols. The atomic number is up here in the left-hand corner. The atomic number is the number of protons and electrons in your atom. So this is not divided between the two. So there's not like half of it being protons and half of it being electrons. It's the same number for both. So there's 11 protons and 11 electrons. That number of electrons can change a little bit when we get to bonds, but for now we're going with the same. So that means don't worry about this positive 1 up here or +1. We will get to that when we get to bonding. So right now, protons and electrons up here is the same number for the atomic number. 11 of each, or whichever element you're using, it will go with that. Your atomic mass down here, we talked a little bit about last week how it has a decimal with it, and how we're going to look at the whole number. So the atomic mass, which is also can be referred to as atomic weight, mass is more accurate. Atomic mass is the amount of protons, neutrons, and electrons in your atom of that element. Now, all of these have very small mass, like they're very, very tiny. Electrons, however, are so much more negligible and not really affecting the whole mass that we really don't count them in this. We do, but we don't. So they're there, but really, so we can use our atomic mass to find our number of neutrons. We use it as just looking at kind of protons and neutrons and knowing that the electrons are there. So atomic mass minus atomic number, we talked about last week, leads you to the number of neutrons in your atom. Which, if you need a refresher on that, I'm going to post a refresher lesson on the basics of atoms, because I know it's hard to remember things from week to week, especially when we're back and forth in person and not in person. So, you guys have a periodic table in front of you. I have this one, which I color-coded it a little bit differently without the chemical symbols and stuff on it so you can see the groupings better. So, I'm going to show you guys that really fast. Maybe. Alright, so groups. You, first of all, have groups across the top here, and then you have periods going down the side. I'm going to explain what those are a little bit more in a minute. I just want to show you my diagram here. So groups across the top, they're 1 through 18, periods down the side 1 through 7. So you then have your elements are categorized kind of by what they are and how they relate well to each other. So hydrogen and helium, which are these guys up here, are kind of your outliers for a lot of things. They're kind of weird, but they fall under kind of the same categories. So non-metals, we'll start up here. Non-metals, I have color-coded in black. I believe it is gray on your periodic table. Alkaline metals are down here. Hydrogen is not one of them. It is a non-metal. alkali metals are here in this first group. Your second group is your alkaline earth metals. And then groups 3 through 12 are your transition metals. Now, these guys down here, you see where it's taken out. So, technically, these groups also include your lanthanides and your actinides. So, these guys actually would be down here, and it would extend our periodic table really far this way. But it's hard to have that on a sheet of paper handy to use. So we take them out and kind of cut them out and put them down here. But we know that when it comes to elements that they're similar to, they fall in here. And if you guys want to Google a full periodic table with those in it, you are more than welcome to. I will find one to post on Google Classroom as well. And then over here, we have our basic metals. And this is where it really, it stopped being like by group over here, but especially over here, it stops being a little bit by group as well. So we have basic metals. Then we have our semi-metals in here, which are also known as metalloids. We have our non-metals again, halogens, and noble gases. And those are the different types and ways that we categorize our elements. So I'm going to go over a little bit what they are, and there's also a vocab sheet that is up online for you guys to look at for this. So your groups across the top. I'm saying now, groups across the top. Groups. So elements in a group have similar chemical properties. So for example, the alkali metals here, their property is the fact that alkali metals, they're also known as alkaline metals, you might see it as either one, they're really reactive because they only have one electron in their outer shell. So they all tend to explode when you put them in things like water. I'll post a cool YouTube video for that to Google Classroom as well. But yeah, they are very reactive in explosions. But table salt, if you put it in water, is not going to react because it's bonded with chlorine and it's not just pure sodium. So, don't worry, your salt's not going to explode if you put it in water. Alright, periods, which go down the side. So the period number, you guys, tells you how many electron shells or orbits an element has. So in the case of your Bohr model, it tells you how many rings around the outside out of your nucleus you have. So I already talked about what alkaline metals are. Alkaline earth metals is your second group, right there. Alkaline earth metals are your second most reactive group of elements. So they're called alkaline because when we talk about solutions, we often talk about a pH level and whether something is acidic or basic. So you guys are pretty familiar with vinegar and baking soda. So when you mix an acid and a base, oftentimes your reaction is pretty fun. Baking soda is basic, vinegar is very acidic and tends to eat away at things. Baking soda isn't not going to eat away at things, but it's going to do it in a different way than something that's acidic would. And we'll talk more about that again later once we get into chemical reactions. So alkaline earth metals are pretty basic. That's why they're called alkaline, and they have 2 electrons in their outer shell. So transition metals, those are all these green guys. Man, it's upside down. Oh, the green in the middle. So about 3 to 12 grouping. So transition metals, they can use electrons in their 2 outermost shells, so 1 and 2, to bond with, whereas most atoms can only use the electron that is in the outer valence shell. So they're often pretty shiny, transition metals. You can think of silver, mercury, and they have a lot of electrons in their outer shell. They can have up to 32. It's a lot. Because they get all the way up to having electrons in that 6th and 7th ring. So outside of even where we have drawn in our Bohr models, you can add up to 7 rings outside, because if you look at our periods, it goes up to 7 on the periodic table. So we can have up to 7 rings around the nucleus. And we'll get more into that and how they actually look, because they're not just staggered in circles later on. So halogens, I'm going to skip over a little bit. Halogens are here in group 17. So halogens have 7 electrons in their outer shell, and they can combine with a lot of different elements. The most reactive ones are up here at the top, And then as you go down the line, they get less reactive and less likely to do something if you pair them with something else. Then you have your noble gases. So your noble gases have a full electron shell on the outside. So helium, you guys, has 2 electrons in it. So it has, I don't have it here, but it has 1, 2, which if you guys remember from last week, it's only 2 allowed in here. So it has a full electron shell on that outer shell, and it's really happy. Atoms really like it when they have that outer shell be full, which is a lot of the reasons why they bond, because if they're sharing one back and forth for a little bit of time, they can have a full shell, or if they're sharing 2 or 3, depending on how many they already had in that shell. So they really, really like having a full shell. So the noble gases do not like to bond with other things. They don't like to share. They've kind of got all the toys on the playground, and they don't want to give any to anyone else. They don't want to share. Not fans. So the higher also the atomic number of the noble gas, so as you go down, the harder it is to find it in nature. But we do use things, you might recognize neon. We use neon in signs a lot, as kind of for those lit up signs in restaurants and stuff. So we do use them, they are found, but they are less common as you go down the line. And then we have the lanthanides, which are, on mine, lanthanides are these green ones, which would go in here and shove my periodic table that way, but we have them down here. So lanthanides, you guys, they have 1 electron in their outer shell, and they're all reactive silver-colored metals. And that's pretty much what groups them together. They're very reactive, they're silver-colored, and they're metals. Fun times. And then you have the actinides. This is where it gets fun. So the actinides are just beneath there, and just go hanging out here, and they would be in the 7th period. So the actinides, guys, are all radioactive, and that's where we also get to having some that are found in nature, and that's where we get really to the ones that are made in the lab. And I'm pretty sure on your guys' periodic table it says which ones are synthetic, also versus solid, liquid, or gas. There's a line for synthetic for the color that it is. The ones that have that color are the ones that have only been made in the lab. And how long they stay varies. They don't really like existing. So after that, we're going to get a little bit more into the ones that are a little bit kind of groupy over here. So then we have our basic metals. So basic metals, you guys, on mine are all of these pink ones. So you have a transition metals, and then you have your basic metals. They're all metals. What's the difference, you say? Basic metals are softer than the transition metals. So think aluminum versus like silver. If you guys have ever used aluminum foil, or someone in your house has a pair of like silver earrings or jewelry, don't touch it without asking. But if you can compare the two, foil is a lot softer. You can change its shape and make it into other things. That silver is hard and is just, it's not, you're not doing much to it very easily. And then your basic metals are also the least reactive of all of the metals, which is part of the reason why we use aluminum foil in a lot of cooking, because it doesn't do a lot. Whether you heat it up, cool it down, put weird stuff on it, it just is foil. It does its thing. And then you guys, we have the semi-metals over here, which is that purple line down, kind of stair steps its way down. So semi-metals are also known as metalloids. So they share some properties with metals, but they're really transitioning into that non-metal category that you can see off to the right and to the gases. So they don't conduct heat and electricity as well as regular metals. You guys think of things like copper, conducts really well. These guys, not so much. And they can gain and lose an electron in reactions, which again we'll talk more about when we get to bonding. I just want to clarify that you have that definition here as we go along. Honestly, that's really our periodic table, guys, and how it's organized. I have included the vocab sheet up on Google Classroom, and if you guys have any questions, please let me know, or Miss Laura. You have a scavenger hunt that you get to do, and kind of helps you learn how to read the periodic table. So have fun, guys.